Hello, geometry. Welcome to 4.9, perform congruence transformations. So this is where we're going to slide figures from one spot to another, or we're going to reflect them, flip them over, or we're going to spin it around, rotation. So we're not going to do the dilations yet. We're also going to hit this a little bit later in the book, probably more intensely. So this is just like a brief summary. It's actually a detailed brief summary, if that makes any sense. Okay, here we go. I can create an image congruent to a given triangle. So we can just slide triangles around, it'll be congruent. I can describe directions in chess moves. Okay, that might be a little activity later. So here we go. Find the length of AB. So I don't know if you recall the distance formula. Distance of AB. We're going to take the difference of the x's, square it, plus the difference of the y's, and square it. Okay, so 2 minus 7, that's a negative 5. When you square it, you get 25. 7 minus a negative 5, that's 12. When you square it, you get 144. We have the square root of 169. Oops, 169. And that's 13. Now, I know when you take the square root, you get plus or minus, but since we're finding the length, the distance, it's always going to be positive. All right. In most cases, when you're finding the length of something, I want you to use the calculator program, okay? It's not one of the benchmarks. And it takes a lot of time to start doing lots of side lengths. All right. What is a point? What point is 6 units to the right of 3, 5? Well, 1, 2, 3 is the point right here. We want to go 6 to the right. So if we go 6 to the right, we'll be right here. What is that order pair? 9, 5. Okay, so basically what happened is I took my xy coordinates and I added 6 to the x. Now the reason I'm writing this down is because this is the notation we're going to be using to show the different translations of our triangles. Like translation means how we slide them or move them around. Are these triangles congruent? So this is where I really want you to use a program. So I'm going to go ahead and just work them out. So remember the distance formula is the difference of your x's, square it, plus the difference of your y's, square it, and then take the square root of all that. All right, so I'm going to go ahead and tell you what the distances are. This distance right here is 6.403. This distance right here is 7.07. This short distance right here is 3.606. And again, I got that using the program. 6.403, 7.07, and 3.606. So these two are congruent by side, side, side. But we could have just done a translation. So watch this. I'm going to take this point to this point. To get there, I have to go over 7, down 8. And every one of those points should be over 7, down 8, over 7, down 8. And then you'll see it. This is a translation. So the translation, using the correct notation, I added 7 to each one of those x values. Oh, you know what? I think this pen is orange. That's why it looks like it's orange. In any case. And then the y values are down 8. Okay, let's grab that other pen here. Maybe get a red. All right. So here we go. That was just the examples, the warm-up here. Transformations. Not sure why that didn't come out. There are 3 main types of transformation. A translation. It moves every point of a figure the same distance in the same direction. Okay, kind of like the example we just did right up here. A reflection uses a line of reflection to create a mirror. So we flip it over. Okay. And a rotation. So you spin it around, and about a fixed point, and that's called our center rotation. So let's do example 1. There's a bunch of examples here. Of course, I failed to write any instructions. I want you to just tell me what kind of transformation is happening here. Well, this one looks like it's just sliding over then down. So this is a translation. It's obviously not going to flip over because the red trapezoid would be a little higher. How about this one? And that one looks like it's a rotation about this point right here. How about this one? Translation, the T's just slide down. This obviously looks like a reflection over the y-axis. Crazy, yeah. How about this one? This looks like a rotation. This can just rotate. I know it's kind of weird to describe these when you haven't really learned. This one can just slide. It's up and over. So that's a translation. Translation's your slide. Translation. This one reflects over the x-axis. And this one, it looks like it's a slide over, so. All right. Next page. There's 5 pages here, so if it seems like I'm cruising through here, I am. All right. Now, the translation. So here we go. You can describe a translation by this notation. So the x changes from, this could be plus or minus a. Let's put a little line below that. And this could be plus or minus b. Okay? So which shows that each point on xy on a will slide down 3 to the right 7. Let's see here. Let's just look at this point. Down 1, 2, 3 over 7. 1, 2, 3, 4, 5, 6, 7. So what you would write for the rule would be x plus 7, because that's to the left and right, and then y minus 3. Okay? That's kind of hard to see. Back to the black. All right, example 2. This the triangle ABC is shown. Sketch A prime. Oh, by the way, whenever you slide a figure, the little prime shows the slid image or the transformation image. So the rule says we're going to go to the right 4, down 2. So each point, go to the right 4. 1, 2, 3, 4. Okay, let me do this in the red again because we want to see it. 1, 2, 3, 4, down to 1, 2. I'm going to put a B prime there. Okay, here, down 4. 1, 2, 3, 4. Oop, I'm sorry, to the right 4. 1, 2, 3, 4, down 2. 1, 2. And then to the right 4. 1, 2, 3, 4, down 2. Grab your straight edge and connect. So notice I labeled them A prime, B prime, C prime, showing the translated image. There we go. Pretty simple, huh? These will be congruent. All right, next page. Reflections. Oh, okay. So when you reflect over the x-axis, this image is going to flip over. All right, so this is something that I really want you to pay attention to. So reflecting over the x-axis, this is what's going to happen to the rule. Because look at this point right here. This point is negative 6, 4. Okay, so look at this point, negative 6, negative 4. What's the only thing that happened here? The x's stayed the same. See, negative 6, negative 6. But what happened to the y? The sign of the y changed. Okay, that will happen in all the points of those two figures. All right, reflection over the y-axis. Okay, take a look at this rule here. Very important. So let's look at A here. This point is negative 4, 3. And look at this point, 4, 3. Notice the y's are the same, but the x's, the sign changed. So here's our rule. The sign of the x's changed. So if it was negative, it'll become positive. If it's positive, it'll become negative. The sign changes. All right, so how do you apply this little example here? You are drawing a pattern for a cross stitch design. Use reflection over the y-axis to draw the other half. Okay, so for instance, this point, it's 1, 2, 3, 4 away. So go 1, 2, 3, 4 away. This is 2 away from the y-axis, 2 away. Okay, so down 1 over 2, down 1 over 2. You get the idea? All right, so this will take a while. Be patient. Let's see here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And it should hit right there also. This goes down 1 over 2. And then let's go back the other way. Down 1 over 2. Down 1 over 2 more. Then down 1 over 2 in the other direction. I'm glad there's a pattern here. We are going to go off the page a bit. There you go. Takes time, but you can do it. So all of your cross stitches are geometrists. Is that a word? All right, flip it over. Rotations. I like rotations, and I'm going to put some rules of rotations here. I originally put them on my back page, but I'm going to put it right here. When you are going 90 degrees counterclockwise, okay, the rule is going to be this. Negative yx. So you're going to flip them around. You switch the x and y, and then change the sign of the y value. When you go 180 degrees, this doesn't matter if it's clockwise or counterclockwise. We'll do this for counterclockwise, CC. Okay, you're going to have xy is going to go to negative x, negative y. 270 degrees counterclockwise. Of course, that would be same as 90 degrees clockwise. You have xy goes to y negative x. Okay. One thing that we didn't hit was if you reflect, I shouldn't put that right here. I'll put it on the back page. Okay. So we are using the origin as the center of rotation for this problem. Okay, so that means this is the x-axis and this is the y-axis. The direction can be clockwise or counterclockwise. The angle of rotation is formed by the rays drawn from the center of the rotation through corresponding points. So for instance, let's say I'm going to pick point A. So what you do is you can draw A to that center of rotation. I should do this in another color so you know what's adding on. I'm going to highlight it later. What do you notice about these lines? They're an extension, aren't they? It's like a straight line, straight line. Okay, and then what you can do is measure this angle. Okay, so if you get out your compass or protractor, you're going to see that this is actually a 90-degree angle. Okay, but that's how you would rotate. So take one point, measure the angle that you need to rotate, and then draw your next point. You'd also probably have to find that distance, but it's usually not hard to figure out. So this is good stuff. I really like this. Students have a hard time with it, but then I said, you know what, just learn these right here, okay? This should have been taught to you in 6th grade because I taught it to my 6th graders last year and the year before. So here we go. And some teachers actually skip this because it's taught in geometry. All right, moving on. Example 4. Graph PQ and RS. Okay, so P is 2, 6. Go over to up 6. And Q is 5, 1. So I'm going to connect. And then RS, we'll do this in red, is 6, negative 1. S is 1, negative 2. And I'm going to connect. All right, then I'm going to read the directions. I probably should have read them first, right? All right, it says, tell whether RS is a rotation of PQ about the origin. All right, so the easiest way to do that is that patty paper, okay? So I know I had a paper clip open somewhere. I'm going to punch a hole right through the origin of the patty paper, and I'm going to hold it in place right over this origin, okay? So I'm going to slide this a rotation, and what do you notice? That line is not over RS. So it is not. Okay? This should be fine. So if so, find the angle and the direction. Well, it's not rotation. Please remind me to get a bunch of that tissue paper, the patty paper, for this assignment, if you haven't done so. Ooh, now we're going to do part B. Okay, here we go. Part B. Part B, same thing. Plot for 2. Letter P. I think the game has started because I hear JD shouting in the background. The Brewers game, that is. Okay, 3-3. You know, I should just make him watch the videos as I make them, so that way he doesn't have to watch them later. He probably doesn't even watch them. Okay, and then let's do RS. Negative 2, 4. And S is negative 3, 3. Okay, so I'm going to take out my tissue paper, and we'll get the paper clip, put it right through the hole, the center, hold it on the origin. Okay, notice I also wrote the X and Y axis, or I drew the X and Y axis on there so you can see it when it slides. Okay, and I'm going to turn it this way. I'm going to line up my axes, and what do you notice? It maps onto RS. I only turned it once. Can you see that? I turned it once. So when you turn it once, it's 90 degrees, and I went counterclockwise. Now, if you're not sure which way clockwise and counterclockwise, think about your clock. This is clockwise, because that's how the clock moves. This way is counterclockwise. All right, so this one went clockwise, and now how you're really supposed to do that is, I'm going to take point P. Let's do this in green. Do I have a green on here? No, we have blue. Okay, we'll do this in blue. And I'm going to connect point Q. Let's pick Q. And connect it to the origin, because that was my center of rotation. And remember, what point did that map onto? Okay, Q is right here, this dot, maps onto S. So, I'm going to connect that. Find out how many degrees that is. It does turn out to be 90 degrees. So this is a 90-degree counterclockwise position. Okay, that thing I was going to tell you about, if you're going to reflect something over the line y equals x, the rule for it is xy goes on to, ready for this? Yx. Didn't see that coming, did you? Now if we're going to reflect it over the line y equals negative x, watch this, xy, whoa, crazy y, goes to, I think I made a mistake with this. Maybe not. Negative y, negative x. No, I think that's about right. Okay, so we have our homework assignment. Lots of standards going on here. Not sure why I have a greater than symbol, but moving on. Everybody have a nice evening and go Brewers, even though I'm a White Sox fan.